Magandang araw Pilipinas at sa lahat ng ating mga kababayan na nanonood sa buong mundo. Kumusta ho kayong lahat? Ako po si Bay Joel. Pagpatuloy natin yung ating nasimulang talakayan, konektado sa deuterium, sa Bataan Nuclear Power Plant, sa energy crisis na nangyayari ngayon, at sa potensyal na paggamit ng hydrogen. So, napag-usapan ho natin, napanood ho natin yung mga video sa ilang series na nasimulan natin. Hopefully napanood nyo ho yun. Kung hindi nyo ho napanood, pakicheck nyo na lang ho. Nasa playlist ho natin yan, yung deuterium. Ngayon, yung huli nating napag-usapan ay yung management ng radiologic waste material dahil yung ginagamit na uranium, nagdidecay ho yun. Meron ho yung mga waste pag tapos nung panahon na nagamit na siya. So yun ho ay hindi ho basta-bastang basura. Kailangan hong merong tamang paraan ng pag-manage nun. Kaya isang malaking challenge ho yan sa Pilipinas at hindi lang ho sa Pilipinas, sa lahat ng nag-ooperate ng nuclear reactor para sa kanilang energy. Katunayan yan, ang Amerika wala pang temporaring paglalagyan, no? I mean permanent na paglalagyan, temporary lang. Para kasi ang sementeryo kumbaga, dahil yung radioactive waste material hindi pwedeng basta-basta lang tinatapon or ini-incinerate dahil hindi ho nawawala 'yon, no? So binabaon ho nila 'yon. So parang sementeryo, kailangan hindi lang basta-basta sementeryo na nabubulok at nagba-biodegrade, hindi ho nagba-biodegrade ito. Yung iba 30 years, yung iba mahigit 100 taon, merong iba libo-libong taon. So kailangan secured yun sa isang containment na hindi maglilik, hindi magsisip sa tubig, sa lupa. So yun ang challenge nila, no? So ngayon may mga storage facilities pero hindi ho permanent yun. Although merong isang company na papanoorin natin ngayon, siyang pinaka-main. So tayo ngayon, naintindihan natin na makakatipid nga naman pag nag-operate ng Bataan Nuclear Power Plant. Kaya lang, hindi na pag-usapan, ano yung cost pagka dinispose na yung radiologic waste material. Ang term nga dyan, hindi nga waste disposal kasi containment nga. So, responsibilidad ng bawat bansa yan. Hindi pwedeng sabihin mo na ipasa mo sa ibang bansa. Kailangan meron kang medium of containment sa mismong bansa mo kung saan ka nag-operate. So, malalim ho ito. Okay, so panoorin ho natin. Okay, so yun ang problema ngayon ng buong mundo. Malalaking bansa na walang permanenteng paglibingan ng kanilang mga used radiologic waste material. So, ang Pilipinas ay potential na magkakaroon ng ganong problema dahil kung mag-ooperate nga naman tayo ng Bataan Nuclear Power Plant, alam natin na mag-accumulate tayo ng radiologic waste. So, merong isang bansa na sila ang unang-unang nakapag-establish ng libingan ng kanilang radiologic waste, ano? Ito yung sa Onkalo, Finland Nuclear Waste Repository. So, tandaan nyo, ito ang unang-una. So, panoorin ho natin.
As European countries seek out new energy sources, some are increasing their use of nuclear power, but finding locations to store radioactive waste has been a consistent problem.
So, it's been a consistent problem finding a nuclear waste, facility para ibaon dahil daan-daang o libong taon bago magdidecay yung radiologic material. So, it has to be stored safely na hindi maglilik at hindi mako-contaminate yung environment. So, they have to be extra careful at kailangan yung facility na yon, alam nila na magiging permanent yun katulad nito na pinagyayabang na hindi matitibag, hindi matitinag, hindi babahain, hindi masusunog at hindi kayang bombahin. Ito yung ah, Onkalo Nuclear Waste Facility sa Finland, no? So panoorin natin ang portion ng video para maintindihan natin kung ano ito at anong ginagawa nila, kung bakit nila nasabi na you know, matindi ang ano nila, ang kanilang ino-offer. Now, ang tanong dito, ah, mag-o-offer ba silang mag-store or mag-o-open ba sila para sa ibang bansa na mag-store ng waste material dito for a fee? Yan ang alamin natin, okay? So ito panoorin ho natin itong portion na to ng DW News. It's a German public broadcast service, DW.
Finland is pioneering a system to permanently contain all its spent nuclear material. Some communities there are embracing the waste, as DW's Terry Schultz found out.
Who wants to live next to a nuclear site? Well, this guy for one, and evidently most of the other some 9,000 residents of the town of Eurajoki, Finland. It's the proud home to 3 nuclear reactors and, opening soon, the world's first permanent storage site for high-level radioactive waste.
We get their real estate taxes. It's about 20 million per year.
Eurajoki Mayor Vesa Lakinyami says decades of good relations and no accidents with the Olkiluoto Nuclear Power Plant led his community to actively campaign to be chosen also as the location for the Onkalo repository. The facility is being called a game changer in the nuclear power industry because the waste is deposited so deep in the earth it will never have to be moved. Lakanyemi considers that a win for his town, long-term financial security.
We have renovated schools and we are going to build a sports hall here. It's cost about 8 million euros.
The economic boost from the nuclear industry is welcome, but embracing its waste requires deep trust in expertise and authority, part of the bedrock of Finnish society. Thanks to that and the unique suitability of the actual Finnish bedrock, this country is making history half a kilometer below ground.
Welcome to Onkalo.
When the site becomes operational within the next couple of years, the spent nuclear fuel will be transferred into steel canisters and then copper capsules, lowered into tunnels, and sealed off forever. At the moment, the Onkalo site is still in its trial phase as experts continue finalizing the details of permanently disposing of spent nuclear fuel. With such high-level radioactive waste, there's no room for missteps.
Looked good.
Geologist Johanna Hansen says every precaution is being taken
To ensure that also in the far future that there are no any pathways into the surface. So this facility will store the canisters for 100,000 of years.
Though the project has been underway underground for almost 2 decades, it's getting new interest from abroad. That's due in part to the European Parliament's designation of nuclear power as a green fuel and the push in Europe to reduce dependence on Russia as an energy supplier as it wages war on Ukraine. So Onkalo is getting lots of attention these days, and not only from scientists and journalists. 17,000 people per year come to see this interactive visitor center and take a tour of the facility. Pasi Tuohima heads up communications for Posiva, the company responsible for Onkalo. He says his goal is to demystify the process of nuclear power generation.
A lot of people say that, okay, nuclear is good, but then you have this waste of used nuclear fuel. But what we are saying is that, no, that's not true. We do have the solution for that, and it's completely safe.
Tuohima says he expects more European countries to follow Finland's lead now that they're forced to reconsider how to power their futures.
So, kita niyo ho yun, no? Gaano ka laki yung storage facility na yun, ano? So, it is a problem kung yung pag dispose ng material. Ito yung Orano, Lahig, on the cutting edge of use fuel recycling. Ito yung isa namang approach, ano, yung kanina Ongkalo yung napanood natin, which is this one here. Ito yung kanilang site, Ongkalo Solution for Nuclear Waste. Ito yung kanilang video. Meters down. Dear, malayo yan. For high-level nuclear waste. So efforts talagang gumagastos sila, no? Malaking ano to, malaking funding ang kailangan dito sa ano nila, no? Ngayon, napakita ko kanina yung Orano Lahig, ano, Ongkalo yung kanina, ito yung Orano Lahig, ito yung recycling naman. Iba naman ito, Orano Lahig on the cutting edge of using fuel recycling. Ever since its beginnings in 50s, 60s, 50s pa nagsimula ito. Ito yung uranium na sinasabi nila. A major player in used nuclear fuel recycling. So ito yung kanilang location, no? So high-level materials ang inaano nila rito. So panoorin natin yung video nila about how they recycle. Ito yon, Orano.
The 300-hectare Orano-La-Hague plant is located in Normandy, on the extreme tip of the Cotentin Peninsula. Around 4,000 people work there. Its task? To recycle the energy potential of nuclear used fuels arriving from nuclear power plants in France and abroad. Because having produced energy for 4 to 5 years in the core of a reactor, spent fuel assemblies have to be replaced. And yet these used fuels still contain considerable energy potential, the equivalent of a quarter of the energy produced by a brand new assembly. The treatment carried out at the La Hague plant allows the recuperation of the uranium and plutonium contained in the fuel, amounting to 96% of the nuclear material. The remaining 4% are the fission products. This final waste is conditioned in a safe and sustainable way, as are the metallic structures, which are also non-reusable. There are two tasks, the recycling of nuclear materials on one hand and the optimum waste management on the other. Explanation. Used fuel assemblies are transported from a nuclear plant to La Hague site in completely safe casks. They are transferred to a first workshop for reception and storage in ponds. The casks are controlled, prepared, and then docked with perfect tightness to the unloading cell. Here, as in all cells, complete and extremely reliable automation is used. The assemblies are unloaded, cooled, then placed in a storage pond to enable part of the radioactivity to decrease. After several years in the pond, an assembly is taken to a workshop where it will first be cut, a process known as shearing. The end pieces are removed. As for the cladding, which contains the recyclable materials, it is sheared into 35mm sections. The dissolution step allows the recovery of the material contained in the sections for treatment. Inside the dissolver, the sections are plunged into nitric acid. The result? On one side, sections which have been emptied of their material, which are called hulls. The hulls then follow the same treatment line as the end pieces, the same line used for metallic waste. On the other side, nitric acid containing uranium, plutonium, and fission products. The solvent therefore contains recyclable uranium and plutonium and non-recyclable fission products. The extraction step consists in separating these three materials in two phases. Firstly, the fission products are separated from the plutonium and uranium, and secondly, the uranium from the plutonium. Extractions are carried out in the liquid phase. A solvent is used for one element to have an affinity to an organic phase, while the other remains in liquid phase. Like water and oil, the two elements separate naturally. At the end of the extraction cycles, three separated materials are obtained. The fission products, concentrated by evaporation, uranium, also concentrated by evaporation, and plutonium, which is transferred to its workshop for conditioning. The uranium is first purified. This involves removing the last traces of the fission products. Then it is concentrated in liquid form, called uranyl nitrate, to be recycled again in the fuel cycle. The uranyl nitrate is then stored in tanks, before being shipped to be recycled in enrichment and fuel manufacturing plants. The plutonium contains a large quantity of energy. Its treatment consists in changing it from a liquid form to a solid form. For this, it is first purified, then converted into plutonium oxalate, a pulp, using precipitation. Calcination then completes the transformation of the oxalate into a powder, plutonium oxide. The plutonium oxide is finally conditioned in stainless steel boxes, which are placed in cases, which in turn are placed in containers. Particular attention is given to the airtightness and non-contamination of the containers. After a storage phase, they are sent to the Orano-Melox plant, which makes new fuels called MOX. In nuclear power plants, MOX fuels are used to generate electricity. At each step of the process, the quality of the products is meticulously analyzed. At Orano-Laag, the purity of the materials obtained is systematically measured by chemical, physical, and isotopic analyses. Materials recycled at Orano-Laag have a considerable energy potential. 1 gram of plutonium, which equals 100 grams of uranium, represent the energy equivalent of over 1 metric ton of oil.
Wow. So, laag pala yung kanilang pag-pronounce doon, laag. So, kita ho natin, huwag na ho nating tapusin. Lalagay ko yung link dito. Pag interesado kayong tapusin, panoorin nyo ho. Bisitahin nyo yung kanilang channel at panoorin nyo para matapos nyo to. But this is very interesting. Imagine yung plutonium, which is byproduct na tatakbo ng ilang libong taon bago mag-decay so kailangan ilibing ngayon. Pwede nang dalhin doon. Magkano kaya yung cost? Doesn't matter. The important thing is that meron ng recycling plant. No? So, hopefully, ito yung isa sa mga avenues sa makakatulong sa atin para hindi na natin kailangan mag-establish ng sementeryo ng radiologic waste material sa Pilipinas. Ano? So, ito yung mga, I'm sure, tinitingnan nila na possibilities. Ano? Now, besides that recycling, meron pang isang system. Ito yung binanggit ni ang tawag dito ni Mark Wangko, yung ililibing. Ano? So, ito yung deep isolation technology, how it works. Panoorin natin ito, mga under 5 minutes.
The global consensus is that the best way to dispose of nuclear waste from power generation and other applications is to put it into deep geological isolation. Deep Isolation is the first company to develop a system for disposing of nuclear waste in deep boreholes that can be vertical, horizontal, or other repository configurations that are safe and cost-effective. This video shows our technology using a horizontal borehole. For this example, a disposal canister is about 34 centimeters across and about 5 meters long for a PWR fuel assembly. The fuel assembly is placed inside our disposal canister with no repackaging needed, and then the canister is properly sealed. Deep boreholes can be wider than 75 centimeters without a limit on the length, because drill rigs typically handle pipes that are 29 meters long for drilling. Fuel assemblies can be packaged into our canisters either directly from the cooling pond or from a dry cask transfer. This step is performed in a way that meets the highest standards of worker safety. Each canister is made of a corrosion-resistant metal that will remain a barrier for containment of radionuclides for tens of thousands of years. Burying the spent fuel assemblies deep in the ground provides permanent protection from the long-lived radioisotopes that can be harmful for up to 1 million years. To ensure protection, we bury the spent fuel in rock far below the water table and where liquids have been out of contact with the surface from hundreds of thousands to millions of years. We start by drilling a larger diameter hole. For this example, we assume it is 91 centimeters in diameter and 1 kilometer deep. The depth and size of the borehole is dependent on the exact site geology and associated repository design. A steel pipe called a surface casing is inserted into the hole. Cement is pushed down the casing and up the space between the rock and the casing, providing an additional seal. The cemented steel surface casing provides isolation from aquifers during the fuel emplacement process and provides a reliable, smooth conduit for canister retrieval. We then drill down 1,000 meters and gently change direction of the borehole until it is horizontal. Industry best practice is to make the angle as gradual as possible based on the geology and availability of drilling equipment. At this depth, the diameter is typically only 43 centimeters, just enough to hold the casing and spent fuel canisters. We will only dispose of spent fuel in deep layers of rock that are extremely well isolated from the surface, and where isolation can be verified using established and proven geologic methods. Now let's go back to the surface and look at how we put the spent fuel canisters into the deep borehole repository using standard drilling equipment. For this example, we have pictured a wireline and tractor assembly. The entire process above ground is done in a way that provides a safe environment for personnel and the public. The first canister is slowly lowered down the borehole. Deep underground, the borehole gently turns 8 degrees every 30 meters to the horizontal section in this example. The spent fuel canister easily travels round this gentle curve without any distortion. Wheels on the tractor assembly help the canister move along the horizontal section of the borehole. The first canister is in place. The tractor assembly is released from the canister and withdrawn. This process is repeated until all the spent fuel is in place. The vertical part of the borehole is sealed with rock and other materials. Within a few years, the enormous weight of the rock above compresses these materials and provides an excellent seal to the narrow access hole. A lot of work has been done around the world on using boreholes to provide deep geological isolation for nuclear waste. It is now an established alternative to traditional large-scale repositories. Deep Isolation is the only company in the world with a demonstrated and patented solution for the deep geological isolation of nuclear waste using directional drilling, a technology that allows us to deliver repositories with a wide range of configurations, tailored to optimize the safety needs of a specific location.
Okay, so that's another company. Lalagay ko yung link nila rito sa description natin para mapanood nyo rin at ma-share nyo. So, anyway, they claim to be the only, yung Kalo is also the only. Yung Laag is the only nag-recycle, So, nagkakarera ito sila because, it is a serious challenge for countries that are operating nuclear power energy. But the good thing is, there are services available. I believe itong deep isolation is pupunta sila sa bansa, let's say sa Pilipinas, at yung technology nila, sila ang maglilibing. Pero sa bansa rin natin. So we have options, there's choices. And ngayon, ang Russia, Wala pa akong na-extract na video to support. But meron ng usapin na they are in the process, although dahil sa issue ngayon, there's a lot of information from Russia that's being censored, hindi nakakalusot, kaya mahirap hanapin yung impormasyon nila, but they are working on technology na magre-recycle din, no? Dahil yun nga, katulad ng ginawa nung sa laag, yung kanilang plutonium, nare-recycle nila into para magamit ulit na nuclear fuel. So, China is doing the same thing. Kinakrush nila, kinicrystallize nila, ginagawa nilang glass, and then they use that too. So, merong ang China, meron silang kanilang nuclear fusion. Sabi nga, nuclear fusion reactor shocks the entire industry. Matter of fact, meron silang technology ngayon. Japan wants to buy it for 20 billion. Ayaw nilang ibigay. And US wants to outbid Japan for $50 billion, and China is not ready to trade it. It's called, I believe, Venus 2. Pero wala pa akong impormasyon na nilabas yan dahil I think it's a very sensitive information. But binanggit ko lang ho. Pero may mga tinatawag na breeder reactors at saka molten salts new technology right now. For nuclear fusion. Kasi nga ginagamit na ngayon is nuclear fission. Ang nuclear fission, yung katulad nung latest natin na video is magkakaroon ng collision ng atoms, para mag-create ng heat. Itong fusion, yung napanood natin, ipo-force nila yung positive at positive na usually nagre-repel, ipofuse nila yon para mag-create ng malakas na energy and create a heat. So yun yung fusion. Dahil yung fusion daw, they don't have to worry about radiological waste material dahil nakukonsume lahat. So ito yung pinagyayabang ng China na artificial sun. I think a million times hotter than the sun. Something of that sort. So, ngayon, itong mga fusion na ito, gumagamit ito ng tritium, ng plutonium, and mainly deuterium. So, dyan ho babalik yung ating topic about deuterium. So, sa next topic ho, let's look into deuterium, into fusion technology and deuterium. Dahil yun ang marami sa atin. At saka pag-usapan natin yung hydrogen, which is also a product that, a material that is potentially marami ang mapuproduce ng Pilipinas. Okay, so hanggang dito na lang po, ilalagay ko ho yung link dito at sundan nyo na lang po yung website nila para ho kayo mismo ang makapanood ng ng mga video. So hopefully ho, nag-i-enjoy ho kayo at nai-inform kayo sa mga technology na ito na concerning sa ating Bataan Nuclear Power Plant para maintindihan ho natin, kung bakit kailangan natin ng nuclear power plant at paano natin mimitigate yung mga challenges, paano makakatulong sa bansa natin, sa lahat ng mga kababayan natin. So, hopefully ho, subscribe kayo, share nyo yung information, at mag-comment ho kayo kung meron kayong karagdagang information, kung mga maling impormasyon na i-share ko rito. Kung gusto nyo, kung may corrections ho, i-correct nyo, kasi usapan lang naman ito. I'm not a physicist, I'm not a professional, I'm a researcher, and I'm just sharing the information na nakita ko dahil yun ang napag-uusapan doon sa ating bansa, yung Bataan Nuclear Power Plant. So we need to be educated. Maraming salamat po sa inyong time. Hanggang sa susunod na video natin. Please like, subscribe, and share. I-hit nyo na rin yung bell button ho para pag nag-upload ho tayo ng video, mano-notify ho kayo ng panibago nating video. At marami ho tayo mga magagandang topic na I think, relevant na pag-usapan. Hindi lang katulad nito sa energy crisis, na pag-uusapan rin natin, meron tayong nakisaw-saw tayo sa issue ng decriminalization sa Senate dahil narinig natin na mukhang hindi maganda ang patutunguhan. So naglagay ho tayo ng ating opinion. Ngayon naman sinisilip rin natin yung mga issues na sa palagay natin kailangan yung boses natin andyan at naririnig at nagbibigay tayo ng ating mga mga opinion. So, yun naman ang importante, kailangan ho nating makisali sa usapin. Wag lang ho yung nakikipagchismisan tayo. Kailangan din natin dahil para sa bansa ito. So maraming salamat ho sa susunod pagkikita natin at mag-ingat ho kayong lahat and please pray every day.